Our stream will have foliage we'd like to see, so open the pop-up menu and select Render Options, Land Cover, Other Foliage to render foliage objects. That will include the pine burn ecosystem, so expand the ecosystems in the lower scene at a glance and disable it. Go to the Water Task Mode and select the Streams category. Add component from the gallery and load the small stream. Find the stream vector in the lower scene at a glance and Ctrl-C to copy it. Select the small stream component in the upper scene at a glance and Ctrl-V to paste. Confirm the operation. Reset the stream resolution. Save the project and render a preview. The stream is not rendering in all of the stream bed. While the stream terraeffector radius is 15 meters, the small stream component effect radius is only about 7 meters. Increase it to 16 meters. Where the small stream enters the lake, we can see its elevation is too high. Open Diagnostic Data with the F4 key if it's not visible. The stream elevation is about 2065.3 meters at the confluence relative to the lake's 2064. Go to the Water Material Depth tab and drop the water depth another 1.3 meters to minus 1.6. Your small stream elevation will be different, so you'll have to adjust your water depth accordingly. Save the project and render another preview. Like lakes, streams have beaches. On the Beach Gradient page, the small stream component shows two materials, mud and water plants. Placement is driven by a material gradient texture. Edit the texture, and we see that water depth is the controlling dynamic parameter. At a water depth of 0 meters, mud is rendered. At water depths of 0.5 meters and deeper, water plants are rendered. On the Beach Materials page, mud uses a diffuse color texture, and water plants renders a diffuse color and ecotype. If we edit the ecotype, we see it's made up of cattails and grass clumps. Go to the Land Cover Task Mode and enable the Pine Burn ecosystem. Let's see how our lake view looks with trees. Save the project and render a preview. We're close enough to the foliage that we really notice the lack of shadows. Go to the Light Task Mode, select the Shadows category, and Create. We're creating a new shadow with an attached vector. We don't need to use a vector to bound a shadow component, but it saves rendering time and increases shadow quality. Zoom back a notch in the plan view and digitize a polygon around the Lake View Camera view area. Name it Lake View Shadow and confirm the operation. Close out the component gallery. Reset the shadow resolution. On the Cast Shadows page, select Cast. This controls the casting of shadows by terrain and foliage. Shadow casting of 3D objects and clouds is controlled by their respective editors. The Receive Shadows page determines what shadows will be cast on the terrain. Let's enable the rest of our DEMS in the database editor. Our shadow, stream, foliage effect, and lake vectors are also listed here. Select one of the YNP-10M DEMS, open the Layer page, select the 10M layer, and enable. Save the project and render a preview. We may not need them here, but more accurate shadows are rendered using fractal depth maps. Go to the Terrain Parameter Editor and select Fractal Depth Maps as the method. Fractal depth maps are calculated using enabled render job cameras, so let's make sure the Lake View camera is part of a render job. Go to the Render Task Mode and expand the Render Jobs category. Open the YNP Render Job. It's using the YNP main camera, so change it to the Lake View camera. Go back to the Terrain Parameter Editor and create fractal maps. Start with frame 0 and end with frame 0. WCS will make a maximum fractal depth suggestion, but we'll change ours to 5 to bring out some detail in the foreground water. Open another Lake View camera view in the upper right view. Save the project and render a preview. There's not much difference in these preview renders. We have picked up more black polys in the water and on the beach. This usually means that the shadow offset value is too low. Go back to the Shadow Editor, Cast Shadows page. Increase the shadow offset from terrain value to 1 meter. Save the project and render the left lake view for comparison. That takes care of our black polygons. By default, shadows are recalculated for each render. That's good, since changes to lights, foliage, and terrain mean shadow changes. Once we're done moving lights and our foliage is set, Use File will calculate the shadow map once, save it, and use it for subsequent renders. This saves a lot of render time. Shadow offset is not part of the saved shadow map. You can change the offset value in Use File mode and render without regenerating the shadow map.